Hi, I'm Vanessa and I'm a graduate mechanical engineer at Northrop Consulting Engineers. My client is on the board for an existing school building in Australia and would like to make some new improvements. A significant portion of energy consumption in buildings is due to heating, ventilation and air conditioning. To reduce carbon emissions and meet the Paris Climate Agreement goals, buildings will need to reduce their energy use. This school currently has solar panels and a relatively new ducted VRV air conditioning system. So in my approach to improve the school, I would target actions that reduce the energy consumption, focusing on HVAC without necessarily changing the entire HVAC system. The first action I would prioritise is improving the air tightness of the school building. This adopts one of the passive house principles that has been shown to improve comfort and reduce energy loss. 15 to 25% of heat loss from buildings in Australia is due to air leakage, which leads to degraded indoor air quality, reduced thermal comfort and increased energy consumption and cost. A more comfortable learning environment with better air quality and low humidity has the added benefit of improving the students' ability to concentrate. Some ways to improve the air tightness in the school include weatherizing doors and windows, sealing and waterproofing leaks by injecting a suitable resin, and reglazing old windows. The second action I would prioritise is providing a HVAC building management system, BMS. Many Australian schools have no centralised building control system, as they are typically built gradually, with new buildings added later on. Integrated Technologies Australia has identified that Australian schools spend on average around $200,000 a year on energy, and a large part is wasted during closed out times. To reduce energy wastage, a BMS can automatically or through alerts control the HVAC system for optimal climate conditions when required, as well as control lighting. Integrated room controllers form a part of the BMS and can control and schedule the classroom temperature. To improve efficiency further, additional equipment can be added and controlled by the BMS, including occupancy sensors, so the HVAC and lights respond to the actual number of people present in the room. The third action I would prioritise is providing design measures that reduce the actual heating and cooling requirements of the classroom, in turn reducing the demand on the HVAC system and therefore energy consumption of the school. Thermal losses can be reduced by over 60% when just 5 centimetres of insulation material is applied to a building element. Externally, creating a cool roof by painting the roof white or with a special reflective coating would be a cost-effective method of improving the energy efficiency of the school. Finally, providing external window shading from external horizontal fins or planting deciduous trees will also reduce the cooling energy used by the school. With these three actions, the school will reduce their energy consumption and ongoing cost, provide greater comfort in the learning environment, and reduce their carbon emissions.